So today we will be discussing about Alva molecule. Alva molecule is like a digital worksheet for molecule. It can view molecular data sheet as a grid of molecules or as a spreadsheet. It automatically import data from SMILES and NDL files. This data along with the calculated properties like descriptors and physiochemical details can be used to filter the data set easily. Alva molecule is free for non-commercials and academicians. You can download it for Mac, Windows and Linux. The link for downloading the Alva molecule I'll provide in the description box. So primarily we are going to see in this section that how we can use the Alva molecule for our research purpose. Primarily we will start with importing the data set which I already have. So this data set I have downloaded from PubChem. If you are having any sort of data set which you have manually designed, you can use that too. Or for the practice purpose, you can download any sort of data set using Zinc database, drug bank or any other. Just open it. You can see it's a big database and it contains almost of 199 molecules. But each of the molecules, when you will see, it contains either the free radicals or the mono fragments or the halogen atom or this particular data set which has not been standardized properly. If I go to the structure or if I wanted to view it in a different form, so I can go to the grid and molecular worksheet. So now I can get a little bit of info about this particular molecule. If I'll come up here and go to the structure section, so there are so many aromatic rings which you can see here. If I wanted to view it in the original form, I can do that, aromatic form or Kekure structures. Then primarily I wanted to standardize the molecule. As I have told that this particular data set, if I go to the view and molecular grid section, there are monoatomic fragments which are present. There are different fragments of the molecules which are there. There are charges, few of the molecules are present. Some molecules are having the free radicals. Some molecules are having the halogen group which might be there. So I wanted to standardize this particular one. I'll just go to the standardize and what sort of standardization I want for my data set. So you have different sorts of standardization which you can provide, such as neutralizing the molecules, neutralizing the atoms, remove the radicals. So each addition of the missing hydrogens, remove excessive or exceeding hydrogens, add charge to quaternary nitrogen. So I am going to use each of the following. If you want, you can use the manual and you can use it according to your need. But I would say it's depend on the data set what you are having or what sort of loopholes your data set is having. According to that, you can standardize the molecule. So I'm going to select all of them. You can move up or down manually and set the order. Then I'll just click OK and it will start to standardize my data set. So as you can see, my data set has been standardized. So primarily we can see there has been mono fragments, there has been free radicals which are present, but now in my data set there is no monoatomic fragments, there are no free radicals, there are no exceeding hydrogens. So the standardization took place. Now the second thing which I could do using this Alva molecule, I wanted to check the structures. So if I primarily wanted to check the structures, I can go to the check structure. I will keep the settings default and click OK. As you can see that the number of bond molecules are 7 and specifically total charge 4, charge atom 7. So it has shown to me how many number of molecules are bond 1. And if you wanted to locate those molecules, you can easily do so. You can go to the grid, you can go to the molecular worksheet and search for the total charge which has been shown. So the molecules which were showing the warning will show 1 here. So if I go a little bit of downside, so one or the other molecule you can see up here. So there are very less number of molecules. So it's very, yeah. So as you can see, it can be easily defined or it can be easily visualized here. Now the second thing which I wanted to go for, as we have done the standardization, check the structure for the duplicate analysis. So there might be a possibility that my particular data set are having duplicate compounds or duplicate molecules. So I wanted to analyze how many duplicate compounds are there. So you can explore it. If you wanted to ignore the stereochemistry while detecting the duplicate one, you can do it. While I'll just go for the default setting and click OK. So all the duplicate compound will come in a single color. So as you can see, this particular one, 1, 2 and 3 molecules, these molecules are having the same. These 1, 2, 3 molecules are exact duplicate of each other. Now I wanted to delete all these duplicate compounds. So as you can see, particularly now I have an approximately of 182 molecules. I'll go to the structure, tools, duplicate and just manage duplicates and press. So it deleted 29 molecules because those 29 molecules are duplicate of one another. So yeah. So now the duplicates has been managed. Now there is one more thing which you can do with this particular software. That is, when you will come to the tools, you can go for the scaffold analysis, which is performed it is performed analysis of Burmis-Murko framework or Bemis-Murko framework. If I go to the scaffold analysis, so this Bemis-Murko framework analysis, so it shows me that the number of molecules are having a singular scaffold. So how many number of molecules are having this particular single scaffold, it tells me about those particular molecules. So as you can see, the scaffold one, which is a very primary ring, as you can see, it is from the serotonin, or all the analogs are from serotonin. 85 molecules, majority of the molecules of my data set are from this particular one. So you can go for the scaffold analysis. This can also be done very easily. So as all those things has been done, so you can plot the chart for your data set using histogram, bar plot or scatter plot. If you wanted to know more about it, you can go to the alvaMolecule help section. Once you will go, you will get all the details how to perform it using the graphical user interface for the alvaMolecules. So duplicate analysis, scaffold analysis, molecular structure checker, filter, sort and edit, how to load the molecules, which all the things I have said, so you can go and check it. So that's all for today's video. Just we will be bringing more and more videos. So the next video is going to be on Alva disk, and we are going to see that how we can generate molecular descriptors. One more thing which I wanted to add in this video, that this alvaMolecule can also calculate 88 molecular descriptors along with few of the physiochemical properties. So if you wanted to go and predict those, you can go to calculate the properties. So all the properties has been calculated as I'm saying. So see, so it has the tendency to calculate 88 molecular descriptors and physiochemical properties. Physiochemical properties like molecular refractivity, total polar surface area, log P, etc. You can use it, visualize it, check it. If there is any doubt, you can comment in the description comment box and let me know. Thank you.